All right, this is the video for calculator book pages 21 to 29, questions 85 through 92. So number 85 says, if a trapezoidal sum over approximates the integral from 0 to 4 of f of x dx, and a right Riemann sum under approximates the integral from 0 to 4 of f of x dx, which of the following could be the graph of y equals f of x? This is one where you just got to draw and take a look. So I want to start with the right Riemann sum under approximating. So I want to draw a right Riemann sum on each of these. So here's my right Riemann sum. I start on the right, and we don't know what the interval length is. I'm just going to choose it to be 1. Start on the right and move to the left. Start on the right, move to the left. Start on the right, move to the left. Start on the right, move to the left. Well, clearly that's going to be an under approximation. All right, now I'm going to do the next one. Start to the right, move to the left. 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 That's an over approximation. B is out. All right, C. Start to the right, move to the left. 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 That's an under approximation, so I can't get rid of that one. Start to the right, move to the left. Start to the right, move to the left. Start to the right, move to the left. That's clearly an over approximation. And start to the right, move to the left. Start to the right, move to the left. So look, just by doing the right Riemann sum, we have eliminated 3 choices just by drawing the right rectangles. That's easy. So now I'm going to take a look at the 2 choices that are left. I'm going to erase this and draw in the trapezoids. So here is a trapezoid on this interval. I want to do C first. I don't know why I'm doing C first, but here's another trapezoid. If you notice, sorry, whoops. Let me redo this. If we notice, in fact, you know what? I want to make my trapezoids a little wider so we can see this a little better. Okay, that trapezoid, those trapezoids are clearly under the graph. And this is because the graph is concave down, which means these secant lines lie underneath the graph. Whereas if I do a trapezoid approximation here, here's my trapezoid, I'm clearly over. So I want to be over on the trapezoid, so A is the answer. I think that's a very easy question if you just draw the picture. All right, 86. The base of the solid is the region in the first quadrant bounded by the y-axis, the graph of y equals inverse tan x, the horizontal line at y equals 3, and the vertical line x equals 1. For this solid, each cross-section perpendicular to the x-axis is a square. What is the volume of the solid? This we need the calculator for. We need to get the region. So clear out whatever's in there. I want to put in inverse tan, second tan of x. Whoops, didn't mean that extra part, so let me do this again. Second tan of x. All right, there it is. Horizontal line y equals 3 I'll put in there also. And the vertical line x equals 1, we'll have to do that ourselves. And we're in the first quadrant, so I'm going to make my window, I want to make my x min negative 0.2, let's say. And my x max can be 1. I want to make it 1.2 because the vertical line x equals 1 bounds this region. Now inverse tangent, I'm just going to put in negative 6 to 6 here for the y min and max, and we'll see what we have going on here. So there's my graph. I don't like that graph. It's a little squatty for me, so I am going to make my y mins just a little and y max a little tighter. So here's the region. This is x equals 1, so we're bounded there. And this is y equals tan inverse x, and this is y equals 3. The cross sections are perpendicular to the x-axis, so they look like this. And the squares are kind of coming out at you like so. So we need to get this distance here in terms of x, which we would subtract 3 minus tan inverse x. This gives us the length of our square. The volume integral is the integral from, let's see, well, we're going from 0 to 1 on the x-axis of the area of the cross-section times dx. The area of the square is the side length squared. And so this gives us, if you think about this in terms of like lengths, let's say I was measuring in inches. This would be inches squared, and dx is a little chunk of the x-axis, which in this particular problem would give us inches. So I have inches squared times inches, which is inches cubed. Anyway, we're going to take this, we're going to plug in math 9, integral from 0 to 1. We're going to go parentheses 3 minus inverse tan of x. Whoops, I got to close that parentheses and close the other one and square it. That looks good. Dx, and here we are, 6.612. So here we go, 6.612, final answer. Okay. All right. 87, the function f has a first derivative given by f prime of x is square root of x over 1 plus x cubed. What is the x-coordinate of the inflection point? Inflection point, we look to f double prime. But right now they gave us f prime. So I want to get a graph of f prime, and I want to use that to draw a little number line for f double prime. So clear this out. Y equals, clear this stuff out. I want to go, I want to make a fraction here. To make a fraction, you press alpha, y equals enter. That makes a fraction on the calculator. Second square root of x over 1 plus x cubed. You can always go old school on this and just do x square root of x divided by parentheses 1 plus x cubed. And I want to graph, we don't know actually, they didn't give us a domain here. So, but we do have square root of x, which means x has to be greater or equal to 0. So I'm going to go from 0, I'll go out to, let's say 10. And let's see what this looks like. That's a crummy graph. It looks like there's too much room on the y direction. So I'm going to go -1 to 1, see if this makes it better. And notice I'm doing this trial and error, you know, that's what happens with some of these problems sometimes. Okay, there's my graph. I'm not particularly satisfied with that either. I want to make it even squattier. -0.2 to 0.7, say. All right, well, here's our graph. It looks like this thing spikes and then comes down. So this is f prime. If I want to draw f double prime's number line, I'm looking for the slope of f. So that's the feature I'm looking for, slope of f. So my slope is positive till I get to this point, and then negative everywhere else. I'm decreasing. So there is only one inflection point, and it occurs right here at that maximum. So how can we find that maximum? Well, a few things. A few ways we could find that maximum. I would honestly just hit trace on the calculator and see 1.008. Whoops. 1.008. Not the maximum. 0.473. That looks like the maximum. It's clearly not 0 and it's clearly not negative. So B is our answer. Number 88, on the closed interval 2 to 4, which of the following could be a function f with the property that 1 over 4 minus 2 times the integral of 2 to 4 is equal to 1? Well, I hope that you recognize this is the average value of f. So we're looking for which function could have an average value of 1. Well, let's take a look. I want to take e first. E's value is always 2, so its average value is 2. No good. Okay. Now let's take a look at d. D is linear and going from 1 to 3, so its average value is also 2. No good. Just intuitively, its average value has to be 2 if you're going from 1 to 3 on a line like that, on an interval of 2 to 4. All right, so now we're down to A, B, and C. We take a look at C. I have these two line segments, which each have an average of 1, and they're equal length. I like this choice. Now, A and B, let's see for a minute. If I took, A and B might be a little tougher to decipher here. If I kind of took this little box here, okay, and I looked at the area of that box, that would be 2 times 2, which is 4, okay? Well, that region here looks like it's a little less than 4. I would estimate this area to be approximately 3. And if we're dividing that by 2, my average value would be like somewhere like 1.5. So I'm thinking that's not the answer. Same thing here. If I took this box, 2 times 2 is 4. I'm estimating that this area is probably 1 or so. And so if we're dividing by the interval, the average value would be less than 1. So choice C is the correct answer. This is more of a question where, all right, it's clearly choice C. And the others, maybe you're debating about, but choice C is very clearly the best, as opposed to eliminating. Number 89 says, let f be a differentiable function with f of 2 equal to 3 and f prime of 2 equal to negative 5, and let g be the function g of x equals x f of x. Which of the following is the equation of the line tangent to the graph of g at the point where x equals 2? So let's see. They told us g of x was x times f of x, and they want the equation of the tangent line. So anytime you have the equation of the tangent line question, we write y minus y1 equals m times x minus x1. Well, they told us f of 2 is 3. I'm sorry, f of 2 is 3, but remember, g of x is x times f of x. So first of all, we know that we're getting the tangent line at 2, so I'm going to put that in, x minus 2. And now here's the other thing. We have y1 and the slope. Well, y1 is the y-coordinate of g when x is 2. Well, that would be g of 2, so this would give us the y1. G of 2 is 2 times f of 2. F of 2 is 3, so 2 times 3 is 6. So we have y minus 6 equals m. Well, let's see. G of x was x times f of x. In order to get m, which is the slope, I need to take the derivative. Well, x times f of x requires us to use the product rule. So I'll write my little individual pieces, and I'll take the derivative with respect to x. Derivative with respect to x is 1. Derivative of f is f prime. And so g prime of x equals x f prime of x plus 1 times f of x, or just f of x. So g prime at 2 is 2 times f prime at 2 plus f of 2. 2 times f prime at 2, which is negative 5, plus f of 2, which is 3. 2 times negative 5 is negative 10, plus 3 is negative 7. So there is our tangent line, and choice D is the winner. So you just got to be careful when reading this. You're getting the equation of the tangent line to G, which is defined in terms of f. All right, a few more here. Number 90. For all x in the closed interval 2 to 5, the function f has a positive first derivative and a negative second derivative. Which of the following could be the table of values for f? This one I would just suggest, there's a few ways you could do it, but I would suggest kind of making a rough sketch. So 2, 3, 4, 5 are equally spaced. Now 7, say if you put 7 here, okay, there's 2, 7. If you put 9 here, 3, 9. 4 goes up to 12, so there's got to be a little more space. So something like this. And 5 is 16, there's got to be a little more space still. So 16 looks something like this. So if you were to try to draw this graph, it looks as though it's increasing. I mean, this is one such graph that could go through those points. It looks like it's increasing, which would make a positive first derivative, but it certainly looks like it's concave up, which would make a positive second derivative. Another way to look at this is to say, listen, I'm increasing by 2, I'm increasing by 4, increasing by 3, and increasing by 4. So we're increasing, and we're increasing on equal intervals more each time. So we're going to be increasing, and the increase is increasing, so you're concave up. That's one way to look at this. All right, B, I want to shrink this graph a little bit. Okay, B, so B we have from 2, same kind of axes here. 2, 3, 4, 5. We're at 7 again. I'm at 11 now. That's like 4 up. I'm 14, which is a little less. And at 15, and I'm actually at 16, which I want to put here. So now we're looking at this curve, and I'm going, oh, look at that. That to me is increasing yet concave down. There's my answer. Now watch this. This is how easy this question is. I can eliminate C, D, and E because they're all decreasing. And we know a positive first derivative means the function's increasing. So even if you could not get between A and B, C, D, and E are garbage. So you don't have to know much about this question except that part eliminates three choices. All right, number 91, we have the particle moving along the x-axis, so at any time t is greater than 0, its acceleration is given by a of t as that function. If the velocity of the particle is 2 at time t equals 1, then the velocity of the particle at time t equals 2 is, well, here's the deal. I have the acceleration function, okay? If I integrate acceleration, I get back velocity. And if I integrate it from 1 to 2, I will get the velocity at 2 minus the velocity at 1, which would be the change in velocity. The change in velocity plus the original velocity at time equals 1 would give us the velocity at time equals 2. Because what you're doing is you're adding on the velocity at 1. If you think about it, these cancel, and you just get the velocity at 2. Another way to think about it is, if you pick units for your acceleration, let's say, is in meters per second squared, multiplied by a change in time, which is in seconds. I'm back to meters per second. This is the change in velocity on the interval 1 to 2, and I add 2 to that. So, whoops, here we go. Going to our calculators. We're just going to type in 2 plus math 9, integral from 1 to 2 of natural log ln of 1 plus 2 to the x dx, and out comes 3.34. So 3.346 is the answer. And last but not least, number 92. Let g be the function given by g of x as the integral from 0 to x of sine of t squared dt from negative 1 to 3. On which of the following intervals is g decreasing? If g is decreasing, we look to g prime, whether it's positive or negative. So we want g prime to be negative. Well, g of x is the integral from 0 to x of sine t squared dt. And we know the derivative of this is just sine of, you replace the t with the x, and technically if this were something other than x, you'd multiply by its derivative, but since it's x, the derivative is 1. So here's g prime of x, it's just sine of x squared. So, go back up here, clear this out, sine of x squared, and we're going to graph this thing because we want to see where it's negative. On the interval negative 1 to 3, so I want to go my window, negative 1 to 3. And I will go, because it's a sine function, I'm just going to go negative 1 to 1 here on my y min and max. There's my graph. So where is this thing negative? Well, it's negative from here to here. So I need to kind of estimate that interval. A and B are out. This is 3, so E is out. And I just need to get the intersection points. Getting the intersection points on the calculator, I like to do it this way. I like to put in y equals 0 and do second trace 5. Enter, enter, enter. It's thinking. It's thinking some more. And there's no sign change. So what happens with that is my guess, and I kind of did that on purpose. There's a good reason for that, which I'm not going to discuss, but I got to get closer to it on my guess. So second trace 5. Enter, enter, and I want to make my guess 2. So I'm going to get a little closer. So my intersection point is 1.772, and that's the only interval with one add on it. I thought these were pretty straightforward for the most part, especially for calculator questions. These are definitely more straightforward. All right, so we're done here.